Question 1a, we're looking for us to draw a line of best fit through the data. Now we've got error bars in the data, so the line of best fit has to go through the error bars. So we're looking for a curve, because that's what the points are suggesting, that passes through the error bars. Something along the lines of that. 1b, suggest why why the line of best fit suggests that H mean is not proportional to T. It's not proportional because the line is curved, or the gradient is changing. State the uncertainty in each value of T, and that's for 1c. So we can see on T that each bar, so each increment, is 2 degrees Celsius, okay? And the error bars are going through half of a bar. So it's plus or minus 1. Don't forget the unit. The temperature is measured using liquid in a glass thermometer. So we've got a glass thermometer like this, okay? And the liquid level is rising, length L, and the glass thermometer has a cross-sectional area, let's call it A. State what physical characteristic of the thermometer suggests that the change in the level of the liquid is proportional to the change in the temperature. Okay, so we know that temperature is proportional to volume, and we haven't got volume written down here, but we do have temperature is proportional to cross-sectional area multiplied by length. Now, the cross-sectional area isn't changing, okay? So if the cross-sectional area is constant, so if this is a constant, then what we can say is, as the temperature rises, the length will rise by the same proportion. So the answer is the cross-sectional area remains constant. One E is asking us to calculate the absolute uncertainty in K. Okay, so absolute uncertainty is written with a delta sign. All right, so that means absolute uncertainty, and that is a value with units. Okay, just so you're clear. When you've got a delta sign and then a divide by a value, so for example, delta x is absolute uncertainty in x. If we have delta x divided by x, that means we have percentage uncertainty, or a fractional uncertainty. Okay, and it's a value, and there is no units because it's a fraction, and you could multiply by 100 to get it as a percent if you wish. Okay, and we're asked to find the absolute uncertainty in K. So because H and T have different units, we have to put each one as a fractional uncertainty. So in other words, if I rearrange, I know that K equals H mean over T cubed. So therefore, the fractional uncertainty in K equals the 1 of H mean plus 3 lots, because we've got a cube here, 3 lots of the T. And then we use the graph to find the values. Now, first of all, it's told us that the temperature is 50, so we can go ahead and plug that one in. So we've got 3 lots of the uncertainty, which we found up here, is 1, divided by 50. That's the value they gave us. So that's a fractional uncertainty in T. And then we need to find the value of H mean at T equals 50. So if I go along here, like that, and read it off, it's 0.72, and it's plus or minus 1. Okay. 0.1, sorry. So it's 0.01, that's the uncertainty. That's the increments in the graph, divided by 0.72. And if we work that out, K equals 5.8 times 10 to the minus 6. So this value of K that I've just worked out comes from, let me do this in a different color. This value of K here comes from this formula here. All right, so I did this earlier in my calculator. So that value of K is 0.72 H mean divided by 50 cubed. Okay, so that's that number here. So that's the value of K. And then if I work out what the uncertainty in K is, I get, let me just work it out. Okay, so the uncertainty as a fraction is 7.4 times 10 to the minus 2, which is 7.4%. You just multiply by 100 to get it as a percent. So the final answer is 7.4% of K. Which equals 4 times 10 to the minus 7. What are the units? Meters per degree centigrade cubed.